Hi, we are Group L of Engineering Material. We are doing a group assignment on ductility, resilience, toughness, hardness. Our name is Jaskaran, Rupesh and Ray. After this video, you will be able to determine the definition of ductility, resilience, toughness, hardness, and the factors affecting ductility. First topic is ductility. So ductility is a capacity of a metal to withstand tensile stress from elongation or bending at room temperature without fracturing. Examples are tungsten and high carbon steel are very ductile materials. If we can find ductility from percentage elongation, LF is final length, LO is initial length, LO is initial length. Or we can find ductility through area. AO is initial length, AF is final length. Elongation method is used widely to test ductility. In this graph, you can see the larger the curve is, the better the elongation is. If the curve is smaller, elongation is very less, means the material is not ductile. Factors affecting ductility. Grain size. The finer the grain size, the better ductility is. Example, aluminium with fine or small grain size has better ductility as compared to large grain size. Heat treatment. Heat treatment refines grain size and improves ductility, hardness, tensile strength, toughness, and shock resistance. Atmospheric exposure. Atmospheric corrosion is a significant problem for metals. This oxidation of the metal surface creates a film and mostly occur in the presence of moisture, sulfur dioxide, and hydrogen sulfide, and decreases electric resistivity of the material. Temperature. Yield strength and tensile strength decreases as the temperature increases. Our next topic is resilience. Definition. The ability of a material to absorb energy when deformed elastically and to return it when unloaded is called resilience. It's measured by the modulus of resilience, which is the strain energy per unit volume required to stress the material from zero stress to stress. Our next topic is toughness.
Hi, it's me Rupesh on the toughness. Definition. The declination of material to crack the propagation is called toughness. In other words, we can define that the total energy required to fracture any material is called toughness. Toughness is the property of a material that describes the nature of material to the breakpoint. Toughness can be determined by the following ways. The best method of defining the toughness is plotting a graph of strain and stress curve. As shown in the curve below, ceramic has the small toughness as it has high stress, and metal has a large toughness as both stress and stress are evenly mannered. Polymer has very small toughness as it has high tensile strength. Next topic, factor affecting the toughness. There are various factors affecting the toughness, among them operational temperature, geometry, and the operational stress are the main factors affecting the toughness. Higher the stress level requires higher toughness materials, lower stress level requires lower toughness material. As you know, the toughness increases with the increase in an elasticity and ductility. On increasing strength, ductility increase and toughness will increase. Thus, toughness is a material generally strong, but strong material is not generally a toughness.
Hey guys, it's Ray, and I'm going to talk about hardness. Hardness is a gauge of the penetrability of the surface of an object against unknown applied forces. The impact felt by an object translates to a denting in the external structure. Materials are influenced by wear and tear and a multitude of environmental factors. Knowing the hardness of a material can evade risks of deformation greatly, and the most suitable material delegated to its respective usage. Hardness can be classified into three types and can be observed concurrently. These all imply resistance to plastic deformation. Firstly, scratching. This type refers to physical alteration inflicted upon by means of puncture or piercing, measured in Mohs scale. Secondly, indentation. This variation is caused by compression loading. Lastly, rebound. Rebounding, as name suggestive, measures a feedback of a diamond-tipped hammer released at free fall onto a said material. These are some of the examples of the scale units used for each type of hardness. Scratching has practical use testing coatings, a process in which two materials of opposing strengths are scraped against one another to analyze the needed force to slit through the outer protective layers. Indentation is useful to test metals. Hardness testing can independently debunk or reaffirm whether a strong material is hard. For this type especially, indentation hardness correlates roughly linear to tensile strength.
So this is the end of the video. Hope you guys got the clear concept about these mechanical properties. These four mechanical properties, ductility, hardness, toughness, and resilience, are the key mechanical properties of metal, where they play individual roles but are very interrelated with each other. For the practical life, these components are very important, and engineers should always consider these factors while selecting the metals in any field. So that's it for the video. If you guys have any suggestion, doubt, feel free to drop a comment in the comment sections. And you guys like our video, then please click on the like button and subscribe the video. Thank you everybody. Hope you enjoy.